So today we're going to take our discussion of exponents a step further. Still answering the essential question, why is it helpful to write numbers in different ways? Today we're going to talk about multiplying and dividing monomials. So the first thing we're going to have to do is figure out what that word means. We know what multiplying and dividing are, but we need to kind of take a look at that. So if you look at page 24 in volume 1 of your workbooks, we're going to talk about a product of powers in a minute, but what I'd like to just do is jump down here to just see what that word means. So first of all, the prefix, sort of mono, usually means one, and monomial, means term. So this is kind of the idea of one term. So a monomial could be a number, like 2, a variable, like x, or a product of a number and one or more variables. So 3y, remember we talked about that 3y, there's the invisible dot there. This is multiplication, 3 times y, but mathematicians tend to be lazy and we don't write the dot. And we sure don't use x for multiplication because in higher math, we look at that as being a variable. So a number, 2, a variable like x, a product of a number and one or more variables. So we have monomials here. 1, 2, 3, 4 different monomials, a single term. So we're going to use the law of exponents to simplify monomials. We're going to use what we know about exponents. So first of all, we're going to start with a product of powers, multiplying powers. So we're going to take something like 2 to the 4th, which is a power, and multiply it by another power, 2 to the 3rd. Now, in order to do what we are going to do right now, they have to have the same base number, the same number in the basement. So 2 to the 4th times 2 to the 3rd, we're now going to talk about what do we do to simplify that. So if you notice, we're going to jump down here and we'll come right back up to the rule. You see 3 to the 2nd, which do you agree is 3 times 3? It's 2 factors of the base, which is 3, times 4 factors of the base, which is 3. So right here is 3 to the 2nd, and right here is 3 to the 4th. Now I want you to see how many factors of 3 there are, because we are now going to simplify this using our exponent idea, our law of exponents. We're going to simplify this. We have a common base, and we have 1, 2, 3, 4, 5, 6. So it would be 3 to the 6th. So when we have a common base, we write that common base, and all we have to do is add the exponents. So there are 6 factors of 3. If there are 2 here and 4 here, there's a total of 6. So if we go back up to this example, notice the common base. Both of these powers have a base of 2. 2 to the 4th times 2 to the 3rd, we write the base and add the exponents. So this expression has 7 factors of 2. And that's how we write it using the law of exponents or the rule of exponents. So here's just in general. Notice that we have a variable of a. So as long as the base is the same, it could be a 2, it could be a 3, it could be an a. We write the base, and then whatever the exponents are, we're going to add them. So when you multiply powers with a common base, you write the base and add the exponents. Notice that the sum of the original exponents is the exponent in the final product, the final answer. The word product is the answer of a multiplication problem. So here's a few examples. Now, first of all, when I go to do this one, I see the 5, but this guy doesn't seem to have an exponent. When an exponent is missing, it's not 0, it's the invisible 1. So right here, when you see any number or variable and it doesn't have an exponent, you can write the 1 in. So do you see the 5 to the 2nd times, do you see 5 to the 1st? When you multiply common bases, you write the base and add the exponents. So if you have 2 factors of 5 here and 1 factor of 5 there, when you multiply them, you'll have 3 factors of 5. And we can take this a step further and say that 5 to the third is not 15, guys. Remember our last video, it's 5 times 5 times 5. Or if you use your calculator, 5 using the exponent key to the third will equal 125. Now here, notice it's not a number as a base, it's a variable. So you write the base, which is a c, and you add the exponents, and you would have 8 factors of c to the 8th, 3 of them here and 5 of them there, making a total of 8. So this would be c times c times c, and this would be c times c times c times c times c. 3 here, 5 there, 8 altogether. Now, I really need you to pay attention right now because all of a sudden they threw in numbers in front of the variables. Those are called coefficients. You might remember that from previous years. When you have numbers in front, you can do what's called the commutative property. You can change the order. So I could take this x squared in this 4 and I could flip the order. I could commute them so that the -3 times, then put the 4, and then the x squared times the x to the 5th. Now remember, in between the -3 and the 4 are invisible dots. You can literally write those in. There's 4 things being multiplied: a -3, an x squared, a 4, and an x to the 5th, and you'll see them all down here. But what I'm going to do is I'm going to put the -3 and the 4 together and multiply them, because they're just plain old numbers, like we did a couple of videos again talking about how to multiply a negative times a positive. And a bad thing happening to a good person would be a bad thing, and 3 times 4 is 12. Now remember, we just learned a rule that if you have a common base, you write it and add the exponents. So this expression that looks kind of like a mess up here simplifies to -12x to the 7th. So you multiply the numbers in front and you add the exponents. So having said that, it's kind of your turn. Now on page 24, you're going to notice an A, B, C. This one right here, D, I added. So I would like you to add it to your book. Even if you have to use the green margin space, you can go ahead and do that. But I would like you to try these 4, and I'm going to pause the video. If you need to go back and look at the 2 examples we just did, or 3 examples, feel free to do that. When you're ready, come back and we'll see how you did. Okay, so A, you've got a number base here, so you would write the base and add the exponents. Now, we could pick up our calculator and take 9 to the 5th power, and look how big that is, 59,049. Now, when we have variables, we can't do this. We can't simplify it to a number because we don't know what the A represents. We have a common base. We're going to write the base, and we're going to, when we're multiplying, add the exponents. So there's 3 factors here, 2 there, a total of 5, A to the 5th. The number 1 mistake, guys, can you think of what it might be? It's putting a 6 here and multiplying instead of adding. Okay, C. I've got numbers in front. I've got a missing exponent. So the first thing I'm going to do is I'm going to come in and I'm going to slide in with this M. I'm going to slide in invisible 1 so that I know that that M has an exponent of 1. The next thing I'm going to do is I'm going to look at the number here, which is -2, and the number out front here, which is -8, and I'm going to multiply them. A bad thing happening to a bad person is a good thing, and 2 times 8 is 16. So I multiply the numbers in front, called the coefficients. Now I'm going to write the M, which is the common base, and I add the exponents, but be careful not to miss the 1 over there. It should be M to the 6th. Now on this one, I'm missing a bunch of things. I'm missing the exponent here. Remember, if there's no exponent, it would be a 1. And there's also just a negative in front with no number. We're very lazy. We don't write our 1. So this is actually -1. So I have a -1 in front, x to the first, a -6 in front, x to the third. The -1 and the -6 are called coefficients. When you have coefficients, you multiply them. So -1 times -6 would give you +6. And that's why we reviewed our positive and negative operations the other day. And now we have an x to the first times an x to the third. We write the common base and we add the exponents. And there are our 4 answers. And that's how we multiply monomials, terms that have exponents. Now, before we go further, let's turn our thinking around and say, what would happen if we divided? So I'm going to show you again. We're going to jump down here again, and I'm going to put the 5 to the 7th. Look, 1, 2, 3, 4, 5, 6, 7 of them. And it's going to be divided by 4 factors of 5. 1, 2, 3, 4. Anytime you have this number in the numerator that is same as the denominator, like 5 divided by 5, or 7 divided by 7, or 1 million divided by 1 million, it's the number 1. And that's why they're crossing these out. So 5 divided by 5, that would just be 1. And 5 divided by 5, that would just be 1. And this 5 divided by that 5 would be 1. And you're going to notice there's 4 that can cancel with 4 up here. Now I just have 5 times 5 times 5. I have 5 to the third. Notice this time, if I take the top number minus the bottom, that's how I'm getting the 3, because the other 4 factors up here are canceling with those 4 down there. So when we divide powers with the same base, we subtract. It's kind of like the opposite of multiplying. When we multiply, we add. And when we divide, we subtract the exponents. Top exponent minus the bottom. So we write the common base. There it is. And we take top minus the bottom, and we would get 3 to the 4th. Now, we could pick our calculator up and simplify that using the calculator. Let's talk about what if there were variables. When there's a variable, it has to be the same base, a and an a. We write it and take the top exponent minus the bottom. And they're just telling you here that a can't be 0, because if it was, you'd be dividing by 0, and that's an undefined operation in math. So notice that the difference of the original exponents is the exponent in the final quotient. Now, the word quotient means answer of a division problem. So here's your answer. Here's your quotient. And that exponent is the difference of the original 2, top minus the bottom. So just before we go, you're going to see this little sticky over on page 25, and it says, explain below why the quotient of powers rule cannot be used to simplify the expression x to the 5th divided by y to the 3rd. Take a minute and see what's the problem with that expression. The problem is that the powers don't have the same base. It's an x and a y. So if you have different variables, you can't use this rule. And again, it's the division rule, and the word division and quotient mean basically the same thing. Okay, so here's another example on page 25. You're going to see 4, 5, 6, and 7. I crossed out 6 because this example often just visually confuses students, and it's not worth that. So we're just going to cancel that one out. We're going to look at 4, 5, and 7. Common base, see the 4? So you write the 4 and then 8 minus 2, which will give you 4 to the 6. Now notice they didn't divide the 4s and put a 1 here. Whatever the base is, whether it's a 4 or whether it's an n, as long as it's a common base, you write the base you have and then top minus the bottom. So this would be 4 to the 6. Now this one, you can go to the calculator and take 4 to the 6 and get 4,096. This one, we're not going to be able to do that because it's a variable. We have the same variable, so we write it, and top minus the bottom will give you n to the 5th. So basically, 4 of these n's in the numerator are canceling with 4 of those and leaving n to the 5th, like we saw on the slide a few slides ago. I put on a 7 because the book failed to do this. So I would like you to pause right now. And can you write this one in your workbook? You might have to put it on the green margin. They don't always give you enough room, but there's green margins on either side of the pages, and you're welcome to use those as you need. So write this down and see if you can think about what's going to happen. Pause the video, and I'll come right back in a second. So let me show you on this number 7 that I've added. Let's just take a look at the front and pretend that those powers weren't there. You know, what if it was 24 divided by 8? What's 24 divided by 8? So the coefficients in front of those powers, you still divide as if the powers weren't there. So 24 divided by 8 is 3. By the way, 3 times 8 equals 24. Now we have a common base being divided, so we're going to write that common base. And then we're going to take the top exponent minus the bottom, and 12 minus 2 is 10. So basically, 2 of these 12 canceled out with the 2 on the bottom, leaving 10 factors of x. Very common mistake is to either subtract out in front and subtract here, or to potentially divide the exponents. Let me just remind you that when you are dividing monomials, the numbers in front, don't forget these are being multiplied, 24 times x to the 12th, 8 times x to the 2nd. Those coefficients, you're going to divide the top divided by the bottom, just like these powers weren't here. That's 3. Then when you look at the powers, you're going to write the common base, and when you're dividing, it's top minus the bottom. Okay, so we just have 3 more examples to do with division, and then when we come into class, we'll do a little bit of practice. So the first thing I notice is this is the division. The common base is the number 5, so I'm going to write the 5 down. When I'm dividing, I take the top exponent minus the bottom, 7 minus 4, and I get 5 to the 3rd. You can pick up your calculator right now. Remember, it's not 15, it's 5 times 5 times 5, or 5 to the 3rd, or 5 cubed, which is 125. Okay, I'd like you to pause the video now and try the last 2 by yourself to see how you do. Okay, common base dividing. I write the base and I top number minus the bottom, x to the 7th. Okay, here comes the one like we just did. We have numbers that are out in front of the 2 powers. And oh my goodness, he doesn't even have an exponent. So when there's an exponent missing, that would be the invisible 1. So the first thing I'm going to do is take the numbers in front, and I'm going to pretend that these powers aren't there. And I'm going to take 12 divided by 2, and my coefficient of my answer, my coefficient of what's called the quotient, the answer to the division problem, will be 6. Now I'm going to look at the 2 powers, and they have a common base of w. So I'm going to write the w. And now I need to figure out what the new exponent is. When I am dividing common bases, it's the top exponent minus the bottom, and I end up with an overall answer, by the way, quotient of 6w to the 4th. So just to remind you, before we go, let me go back. If you are multiplying common bases, right? If you're multiplying, you write the common base and add the exponents. If there are numbers out in front, the coefficients get multiplied. So when you are doing the product of 2 monomials, you multiply the coefficients and you add the exponents. When you are doing division, you divide the coefficients and subtract the top exponent minus the bottom. Those are the 2 new rules that we've learned, multiplying and dividing. It is now time to practice. So when we get to class time, we'll give it a little bit more practice. Have a great day, everybody.